Good evening, everyone. Hope I'm audible. I'm Professor Ramya, and along with my co host, Professor Aishwarya, it gives me immense pleasure to welcome you all once again on behalf of Computer Engineering Department of Risby College of Engineering to Day 2 of ATAL Faculty Development Program. A warm welcome also to all our FDP coordinator, our beloved principal, Dr. Varsha Shah ma'am, coordinator, Professor Shiburat sir, our respected Dean of Academics, and our Head of Department of Computer Engineering, Professor Mohammed Junaid sir. I warmly welcome our deans, HODs, coordinators of various departments, and all the faculty members present here. I extend my welcome to all respected faculty participants from across the country, along with our organizing committee. I extend a warm welcome to our eminent speaker for the day, Mr. Mitesh Singh Jatt and Professor Pallavi Dongare. We sincerely thank the management of Risby College of Engineering and AICT for their constant encouragement and support which has made this FDP possible. Now, I request Professor Aishwarya to kindly introduce our esteemed speaker for session 3. Over to you, ma'am. Aishwarya, ma'am, can you start with the profile introduction?
Ma'am, you can continue.
Okay, sir, I'll proceed with it. Just give me a second. Yeah. So I believe there's some issues with the internet. So I'm taking over, ma'am. So rest apart, it is my privilege to introduce our next distinguished speaker, Mr. Profesh Jatt. Professor Mitesh Jatt, with 18 years of experience, Mitesh Singh Jatt is a seasoned tech professional specializing in DevOps infrastructure and data engineering. He has held pivotal roles as leading companies including Joysys, RCSM, Cred, Twitter, Ola Cabs, and Yahoo. His expertise in AI/ML is demonstrated through projects like designing and implementing a scalable ML ops pipeline with blue-green deployment for seamless model rollouts at Cred. He has also worked on big data analytics, leveraging user data for segmentation and URL classification. Mitesh sir holds an ME in Interest Science and Engineering from prestigious Indian Institute of Science, Bangalore, and an MS in Advanced Networking and Telecommunication from the International Institute of Information Technology, Pune. His background includes work on wireless LAN, device fingerprinting, strong academic foundation combined with extensive industry experience, makes him a leader in building and scaling robust, intelligent, and distributed systems. We are delighted to have Professor Mitesh Jatt with us today, and I'm confident that his session will be insightful and thought provoking for all of us. We now invite Mr. Jatt to deliver his session. Over to you, sir.
Yeah, thank you, Ramya ma'am. So I would like to thank AICT, Rizvi College staff, principal ma'am, and HOD sir of computer science, and Anupam Chaudhary sir for giving me opportunity to speak at ATAL ADP. Thank you so much. So I'm going to speak on. Let me share my screen first. My screen visible?
Yes, sir.
Yes, sir, visible.
Uh, so yeah, I'm running like on Linux, so there might be some jitter, but uh, because in industry most of the deployment happens over Linux, so I'm using Linux to demonstrate means presentation along with some hands-on demo of using AI in day-to-day life. So, welcome everyone. Thank you for joining me. We are here to discuss a topic that is not just at the forefront of technology, but also of our society: the ethical, practical, and future implications of artificial intelligence and machine learning. So, today's agenda is over the next 90 minutes, we'll break down into three key parts. We will start with we'll start with ethical questions, then move to the real world challenges faced by the companies in deploying AI models, and finally we'll look into next what are things going to coming few years, and then we'll wrap up in uh, some time for your questions. Also, if you have any doubt, you can ask in between in the chat window. I'll after end of every slide, I will look into the chat window and try to answer. So, so I brief about anyway. Ramya ma'am has told, so I'm skipping these things. So, yeah. So, say you start your day. Now, earlier, what was AI/ML was like only to academia, general data science students. Generally, I have studied AI in my B in 2002 to 2003, but I did not know that I going to catch up this much. Uh, so nowadays it is general, like every day whenever we start our morning, we see like our navigation in car. If we are going to office, we see we get navigation, even Alexa at home, and our assistant, like a smart assistant, can tell what is the weather would be. So all these places we are going to see AI. So so it is not like a futuristic concept. When I was studying, it was very looking like futuristic, but nowadays it is generally part of our lives. And we have seen like auto driving cars from Tesla and Waymo. Those are having they can come whenever you say pick up me from this location and drop me at that location. That is like already in trial mode in US. And so we are seeing a lot of innovations since in AI since the corona. uh, so that is there, but so this presentation will explore the core ethical consideration, the practical challenges of deployment, because model creation on laptop looks easier even to demo, but when we get a lot of traffic on it, they start to stutter or fail. uh, and the exciting future, like what is going to happen in AI. And I will also do some demo of, because most of the theories have been told by yesterday's eminent speakers, pronouncer and another pronouncer, about AI evolution and all. So I'm not going to cover all those things here, but I will uh, do add-ons here, like in real life how AI can be used as a some demo in between. So is there any question for now? You can type in chat window. I'll go to next slide. So my screen is visible, correct? Okay. So
Yes,
first,
sir.
yeah. So let us first do some one AI. I have written just how many of you are generally fearful of using Linux command line or command line on any Windows or Mac OS? So uh, you can either give like expression via reaction or type in chat window. Do you still fear like terminal is harder to use because you don't remember commands? Correct? Hello? My screen visible, correct?
Yes, sir. We
Yeah.
can see the terminal.
Okay. Terminal fonts are visible, or should I increase the font one more?
A little bit more would be helpful, sir. Yes, yes, sir. Perfect.
Okay. Okay. So say if I want to say merge multiple JPEG file into PDF. So I don't remember the command. So if I type picture files into a PDF, so it will go and find out some useful commands for us. Let us see. See, it is so easy now. So now you can copy paste and run commands, which will be helpful for you. So what in behind it is doing is that it is like taking all these parameters and go to my local Olama server. So it has come here and given this input and told it to find out what can be done for this in Linux command. So it returns me this. So in that way, Linux command line become easier. It is more easier now. So this is just one example I'm giving to uh, show like people can take interest in learning Linux or any other like command line. So AI is helping here. So this is just a demo. So I hope you are found this useful. So, okay. So any question related to this? No. So okay. So first thing is that ethics of AI ML. So core question is that so this is the central question in AI. Because we can build it, should we build it? We can easily build something which may be useful for others, may not be useful, and how it is going to be used. That is the always a question, and so it has many aspects of it. For example, from engineering perspective, how we can build it, and data science, how it is going to like create models, and from like users perspective, how it can safeguard their interest and it should not return results which will be harmful for everyone. So so that is what it requires studies in multiple areas and avoiding risk. So we have the capability to build incredible things. So we have seen in Corona, because people are limited to their home, they are not able to go to office. So to mitigate that issue, this thing has started, and to so that minimal people are required to create something new which are already solved. So in that manner, AI development has been started. So key ethical pillars of AI are fairness and non-discrimination. Sorry. Uh, so it means it should return results based on question, and it should avoid using any bias. So avoiding biasness is the biggest challenge, because we have seen issues related. So whatever input if we are our training data is not good, the model will not be returning good results. So that we have observed. Second is transparency and explainability. Is my slide visible?
Yes, sir.
Okay, great. So and third one is so explainability means like how model is generating output, that should be explainable to at least audit authority. So that is required. And third point is accountability and governance. So that say if model is generating something, it should have all the logs, how it is generating, and so that if it is required to verify that whether model has generated this output at some point of time in previous timeline, so that we can see uh, what has been done, why this output has been generated. That kind of things should always be there. The fourth point is privacy and security. Sometimes people have hacked models to even know how it was trained by model itself. So those things also needs to be prevented by AI models and the people who are creating it. Next, any question till this point? Okay, next. Okay, so first ethical pillar is fairness and algorithm bias, like so that it should not come in like output. So the problem here is uh, so it is a kind of black box problem. So imagine AI denies you loan, but no one can explain why this is. Say you went to the bank to take a loan, but AI has denied the loan. So you never know. But in our current system, we are using civil score. So we ourselves can know that due to our lower civil score, loan was not granted. But say if bank is using AI system and it has denied your loan, so without explanation, then that is another black box kind of problem. So if transparency is not there, we can't challenge the decision and identify error, even though because models can give a result with certain percentage of accuracy. For example, one incident happened, a company require recruitment tool because it was trained on, because in most companies generally males are more, so it was trained on that data. And when say as timeline progresses, more female candidates started applying, so they were like denied like candidature. So that happened. And if I go to this side, so you can see the company Amazon, because so it was showing it. So this was news in Reuters. So that is the issue. So if a data training data is having some bias, it will result in biasness in output. And another thing, so predictive policing algorithm can disproportionately flag specific demographics for surveillance, and that is also a problem. So what is the solution for this? So we need to like take data from multiple sources, so that say even if one is biased toward one thing, another may be biased for another thing. So both can cancel out one another. And more the source of input, and the more the better results we'll get. And we need to implement a bias detection and mitigation technique, uh, so that even we can try to see create our own, like in software engineering we can write test cases. Similarly, we can write a bias testing, uh, another AI model which detects the bias. And uh, and uh, we can ensure multiple teams are building same, and say in partition manner, so that if one team does not catch some bias, another team can catch. So in that manner, things can become better. Okay. Any question till now? Eh, Okay. So second pillar is transparency and explainable AI. Many complex AI model produce a particular deep neural network are black boxes, and their decision making is inscrutable to humans. Uh, as we have seen in earlier example, why without transparency we can't challenge decision and identify and errors and build trust. So it has some real world impact because user must trust the AI decision is fair and logical. Generally, we use for our software development. So if say it does not give correct answer for more than 70%, then we stop using that model because our more time goes in debugging then. So so for us it is a kind of not much black box. At least we have some testing, but for some places where user is asking for something new, there is no scope for validation there. So in that case it is if we don't have trust, we cannot trust the output there. And compliance also, like some now things like GDPR, European Union has come to like right to explanation for automated decision, because they have seen that it is required to regulate AI related output and solutions, so that things will become more good for human. So is solution for this problem is developing techniques to make model more interpretable, uh, uh, and even model should output the things which are like debuggable and providing auditing information. Any question till now?
So there's a
Yeah,
question
yeah.
in the chat. Yeah.
Yeah. So we can use like certain labels. Even we can have multiple base different models, so that say we are trained on some data, and we can even invert the data such that it becomes a bias to other side, and then we can create model mix of both. So we have known for like mix of experts models, MOE models. So in that manner, we can avoid this kind of biasness. Even we can have human interaction for correcting the bias. I hope I'm able to answer the question. Third pillar is accountability and governance. Yes, yes, sir. We need to verify whether a model is giving biased result or not before deploying. Correct. Yeah, because that is why testing should be done before deployment. So we do two kind of testing. One is unit testing, and second is like integration testing, so that this model is how it is behaving with other models also, with other APIs in uh, our system. So two-way, and one is manual testing is also done for end-to-end testing. So by deploying multiple testing elements, give us better safety against a bias. So the third pillar is accountability and governance. So who is responsible means this main question is there. So huge area of legal and ethical debate. If an so for example, a autonomous car comes on street, and say some accident happens, who will be responsible? Like the car manufacturer, or the software developer, or like a model creator, like data scientist, or the AI itself to blame? Means, so who is the responsible? So those kind of things are still like in not means those are in still development. but those should be like governance and accountability of AI related um, stakeholders should be there. So those are getting defined. For example, European AI Act, we can see. Okay, so we can see like so this is defined by European Union, so they are good in like creating these governments. But yeah, in India still we are waiting for our compliance from government of India, but they are there. So they like for GDPR means to store the user data and delete the user data when users unsubscribe from a service. So that is defined. So similarly, they have created this compliance checker for. So the European Union AI Act is a prime example of comprehensive framework that classifies AI system by risk level and impose strict requirements on high risk application. So wherever high risk is there, for example, medical related things, say someone has deployed AI to suggest user some medications, then and this kind of yeah, like AI actor should be used rigorously, so that if AI should not give like a wrong answer, wrong medication to any patient. So next one, fourth is privacy and data security. Okay. So say there are two kind of privacy. First is like privacy related to user training data. If it is having say some credit card information, and if AI is trained on it, and I try to search say Mitesh credit card number, if AI can emit that, then problem. Correct, because then the PCI DSS uh, related certification has not been passed by the company which has taken your credit card information. So that is one related to privacy. Second one is like even it is generating some information, though then model should not emit information related to company and how it was trained to normal users at least. So that is a and so there are concerns related to like data is the fuel of the means uh, earlier petrol was the main fuel, but nowadays data is the fuel. So with great data comes a great responsibility, and sheer volume of data collected by AI systems poses a significant risk to personal privacy. So how can we protect data? Okay, so we have seen consequences of data breaches like password or user logins have been emitted by like many companies uh, who are holding your password or any PII data. So that to avoid so government can put like a strict data protection law like GDPR and CCPA, and other things are like we can use to find some earlier models means data can be filtered out or anonymized before even used for training. That those kind of techniques can be used. And fourth one is like nowadays it is coming like a small level language model or small models which can run on your personal machines like laptop, mobile. So in that way your data won't go out. So that can be used So I'll show one example, working example for that. So in that way, privacy and data security can be used, and your data can prevented from going into wrong hands. Any questions till this point? So one section is complete. Okay, now another example of demo. So how AI can be used in AOps. So I'll show one small demo. Say, for example, we are collecting. So I'm showing all real world examples so that you will get encouraged to use AI in your daily life, so that uh, you get like eagerness to learn more about AI. If you use something, you will remember always. But if you like read, you may forget after 10 days. So that is there. So for example, this is like reading the means a container orchestrator system. So here some developers have given some configuration for their containers, like my container needs that much CPU and memory. Let us see how AI can help. For example, say I have some dummy data of some services. So say I select cluster, means ECS cluster. ECS is just like Kubernetes, but it is managed by AWS. Say I get this matrix of this. So I have 30 days data. It is too many data that it is not visible, but you can see rough dots, circles are there. So it's a CPU usage is around one. Developer has given one, but it is like by heuristic we are getting like CPU usage is low, generally only one or two spikes once in a week. So that indicates that CPU usage can be means we can give a small CPU to run this service. So I'm around going to say one fourth, means only three-fourth of cost. So that is the advantage. So currently this is given by heuristic. Let us see how it is given by AI. So now it is going to with this heuristic, it is going to AI to tell me is this correct or something missing. So we can use like, so it has told like we can increase CPU, but memory we can keep it like that, because memories is never gone above 14. So it has suggested to decrease memory usage, so to half, one fourth rather than one eighth given. So it has given explanation why it has told to use CPU usage higher, and given the, but yeah, Olama is like memory model, but it gives a certain information to you, so you can select which is best for your service. So this dashboard is given to developer. They can select based on either heuristic and get both, whichever looks good. So this is too low. So better 5112 is better suggested by, so Olama means Llama LLM model. So in that manner we can use this is only for service, and it can use a database also behind the scene. So we can see that also. One other example, we can run this. So it will combine both. So here also it is suggesting same, and so you can see instance type also it is giving, means we can so it is suggesting to increase the but due to database connection count, and it is saying, oh, it is over provision x large to you have to decrease. And if I use olama, then no, it is also suggesting same, like it is suggesting to decrease the instant type so that I can save 50% cost easily. So in that manner I can utilize AI to save cost to company. So this is one example. Any question on this? Means I'm showing real world example so that you can see there are many variety of things you can do with AI. Any questions, or should I go to next slide? Okay. Now second section is that current challenges in AI. Okay. So main challenge is from development or like initial POC, proof of concept, to actual deployment. There are many hurdles and challenges we face. So in the AI world, we have a saying: get a model to work once is a sign. Once it is a science project, getting it to work in production is an engineering problem. So creation of model is like data scientist uh, task. After that, taking it to production means because in developers or data scientist laptop, only one or two requests he will do to test it, but in production generally 1,000 requests per second can come to that model. So one machine or one container cannot handle it. So how we can make it like parallel deployment? So Preeti Tiwari, I have given some example of problem solving process of AI. Come again. Can you explain better? Like, what is the example you are looking for? Like,
Sir, actually, I am a teacher of AI and I am teaching problem solving and
okay.
back end process of AI का जो भी होता है. I
Mhm.
wanted to give some example to my students, but I'm not able to find like exact process of finding solving some problem by the AI, how it works. Like if you can show some flow chart or some algorithm, something like that, how
Okay.
it works.
So
That
that those two things which I have shown, flowchart I have not created, but I can show. Uh, Let me run. Okay, let me show here itself. So how did I solve that? I can show with flowchart. Say one problem, na, which I solved. Just now I showed one thing, correct? So one problem I was getting is that developer have given like CPU and memory configuration higher than required. So my problem was to save the cost for company because it was going little higher on the higher side. So how can I save? So first what I did was collecting the metrics. Means so first problem in any data science problem is data collection. Means sorry. So after data collection, my screen visible, correct?
Can
Hello.
you please increase the font size?
Yes, sir.
Yes, yes, yes.
Yeah. I will, just 1 minute. Font side better. Yeah.
yes.
First one problem is data collection. Second problem comes is so first after data collection you have to clean it, or so data cleansing comes in picture. Okay. Uh, okay, so that it becomes in next example I'll show exactly what is happening, but yeah, Means here also, if you have noticed that I am reading, so this is metrics I have collected from say AWS CloudWatch, which give metrics of CPU usage and memory of particular container over a month. So I have collected that and kind of put it in CSV. So that is data cleaning part, so that I'll get every record as a separate entry. Hello? Yeah. So after data cleaning, I create a model. Means on top of that, or train. This data can be used for training plus testing. Some part of it will be put in training, and so and some part is put into the testing part. And then model is created. Can say this model, and then it is getting deployed in uh, any server, say for example. And when user comes, for example, then user will connect that to this deployment, and this deployment will connect with a model and get the data based on input. So this is how that flows runs. So that is what I have done here. If you see, uh, so I ran this command, this file, correct? So you can see I am reading two files because I need to read two data. One is for CPU and memory usage of service. Second is it's a database, what metrics. So there I collected metrics from two different in two different places. Then I created this CSV file. Let me show you this file. Okay. You can see this much many lines. I am feeding to the. Okay, so it is showing that CPU utilization metrics on this time. It was like 2 point this percentage. Okay, a minimum, maximum means average, maximum, and minimum. So in that manner, I can put. So see, so it was like earlier it was in JSON data. I have converted it to CSV. So that is the second thing, data cleaning. And then in this code, I'm using some heuristics. Okay, so I have computed like how much CPU memory are required by one container and all those things. So this information is then given to like Olama, which is running here, and it returns the value. So this is a very simple example, but like useful for me solving my uh, day-to-day task. Instead of analyzing everything, I'm able to solve it here.
Sir, may I ask you something else, sir?
Yeah.
Sir, if we are asking something to AI on search or some chatbot to do some task or solve some problem for us, how does that search process work? If you can explain it in some lines or with some example, that would be helpful.
So I can tell you in terms of very simple thing. You have heard of Markov chains, correct? For example.
Yes, sir.
Yeah. So So for example, this is one example. Say weather forecast. Okay. So I know if it is raining today, tomorrow there is a probability of 0.5%. So it is giving me, similar can be used for language model. Actually what AI is doing is that, let me show. Say if I type say hello. So generally in programming, if it is a coding model, it generally will return mostly world. It will return an array with probability, kind of say world with 0.9 90%. Okay, world 0.9, and it will return say hello. Say mostly if it is Alexa, it will return 0.6%, and more, say for top 2 3 values. Then it will decide which one should I put. So it is seeing this for I'm explaining in simple example. So it is seeing that this is the higher probability, so it will try to use hello world. So it will print hello world. So this is the actual. So you can, so this is the similar way. So this is like we can store in matrix, 3 by 3 matrix, rainy, cloudy, sunny. And if I want to know from rainy season, which thing is going to come tomorrow, rainy or, so most probably it will be rainy tomorrow, but there is a probability that cloudy. So if we give like, so yesterday was rainy and next day is not raining, it may be cloudy. So because earlier already rainy happened. So because zero point 0.5 into zero point 0.5 is now 0.25, that is less than 0.3. So next day it may be cloudy. So in that manner, we'll come to know that what is the next word. So LLM is, in simple terms, is finding the next word with greater accuracy. I hope I am clear by explaining in this simple manner.
Right, sir. Thank you, sir. Thank you.
Yes, yes. So it is like more sophisticated next word prediction. Earlier it was NLP till GPT-2, GPT-2. After that, like deep learning and those things have like more vectors. So see, these are a small problem and we are having 3 words only. But number of words increases, then vector becomes like nth dimension problem. So to solve that, we use like graphics process GPU to. That's why GPU is used to compute parallelly.
Sir, some like AIs show the websites also that from where they are picking up the content. So how does that like search begins? Can you just explain that?
So Google search also works on this this model only, Markov chains. Google search. If you see Google page, say rainy is one website and then a cloudy is another website. If say raining is getting more incoming, like with higher probability, then it will be ranked higher. So that is the page ranking using Markov chains. So actually using Markov chains, they have migrated the word prediction problem to website prediction problem. So that is the actual Google page ranking algorithm. That's how Google search give better results. So in that manner. So for example, if I have given Markov chains page ranking, see it comes to know easily. Correct. So that is the advantage of so this is the basics actually. Markov chains helped us in like creating certain solving the complex problem next word prediction. So in a simple, not very layman term, but it is easier to explain to students in terms of like, if we know this how to predict next word, uh, things will look easier. Otherwise, deep learning, machine learning makes little complicated to understand, because we need to imagine nth dimension things in vector. Okay. Yeah.
Right,
So
sir. Thank you.
explaining things by this picture is easier than explaining by matrix. If I write this thing in matrix, it will look a little complicated, but let me show. If I put it in if I put it in matrix, it will not be like as intuitive as this picture. Say I have matrix of like 3 by 3. Okay, so first one is so rainy to rainy is 0.5, rainy to cloudy is 0.3. Now it will become maths, and it is good for computer, but okay. uh, Second array means a line will be rain. Now second is cloud to rainy is 0.2, 0.4, sorry, 0.2. Cloud to rainy is 0.1, and sorry, cloud to rainy is 0.2, cloud itself is 0.4. In that manner we can write. Okay, cloudy to sunny is 0.4. So we can represent this, and computation becomes matrix multiplication and transposing things. So in that manner we can do. Okay, so this will be closing. So in that manner we can do mathematics over it and easily predict what is the next word maths problem. I hope I have answered your question.
Thank you, sir.
No, thank you. Okay. So similarly, I have solved the similar problem of predicting the like what will be the actual usage of CPU and memory, so that, and literally I have saved around means 40% of total cost by using this, because I have given dashboard to developer. Now they can go and simply see their own things, and simply instead of like creating Excel sheet and saying that you go and decrease your CPU usage and memory. Okay. I'll go to next one. Okay. So what is current challenges in data? So problem in what we have seen, like the main problem here is taking the model to production, like serving it consistently, and scaling according to the number of requests. Running on a single laptop is much easier, but say if your laptop goes down, how will you recover your data also is a problem. So similarly, so first one challenge is actually uh, what, sorry, my previous slide, yeah. Okay, so their key challenges are like data quality and curation, scalability and infrastructure, uh, and deployment and integration, then model drift and maintenance. These are four challenges generally currently industry is facing, and we are having some solutions how we have improved the things better at our side. So first challenge is like data quality. If our data is not good, we'll get not good output. So this is the issue. Uh, So raw data is really in perfect format. We have to always put that's why I put this stage is very crucial. Okay, my bad. I should have included this diagram, but I thought it has been showed in earlier presentation. That's why. Okay. So what is the problem with like data quality? One is inconsistent data. Means so even say there are many website, for example, for medicines, like 1 mg and other. So they have different format. Some show first the problem that medicine is solving. then shows reaction and other things and dosages. Some may show dosages earlier than reaction, and so order may different, format may different. Even some may be missing or incomplete data either. So it can lead to skew and unreliable model. And even say annotation, say even if you use a human to uh, label the data, if say some typo happens, uh, what about security? Security is a challenge. So that is what anonymization and other things come in picture, so that our providing confidential sensitive data, it won't become a problem. And solution, invest in robust data pipelines. Like we should be having proper data pipelines with multiple phases of testing and cleaning and data validation. So what is the cost of bad data? It can lead to poor model performance, can even introduce bias. First step of any successful AI project is significant investment in data engineering and cleaning. So if we are planning for like having AI ML models deployment, they should have a strong data engineering team. Until data is proper, it is very means if like what foundation is not good, building will not survive for long. The second challenge is scalability and infrastructure. So a model that runs on single computer for a proof of concept is very different from one that needs to be handling millions of requests, uh, even per day or per hour. So training large models like modern LLM requires immense computational power and can cost millions of dollars. So what is the solution? We have to like dedicate our time in model optimization so that it can handle more requests per second. Uh, Instead of like one or two requests per second, it is kind of slow. Say if you are getting 1,000 requests and your model is able to handle only one request per second, then you have to deploy 1,000 machines. If you are deploying one model in one machine, and 1,000 machine cost a lot. That is the problem. So that's why we need to try to solve in multiple or so fast model should be fast to respond. Means its turnaround should be less. And like how to deploy in parallel, we can use ECS or Kubernetes for resource management. Means one model gets deployed in thousand of containers behind load balancer. So that can, I'll show one model. Means I've deployed this in CRED earlier. So this is the typical pipeline which requires like proper testing and many things. So first, like developer develop means data scientist develop code related to model. It goes to Git. Then it is pulled and security scan happens for that code and data, and it builds the model, and then runs some initial unit testing, as I have told earlier. So if testing is failed, then it won't go ahead. Otherwise, it will create container for it and put in container registry. Then in a stage, actually it is tested. Stage environment is not production, but it will give, say if something happens here, problem, say bug is in their model, it won't affect the production, so that consumer will not see anything wrong happen. So that is the advantage. So if it feels successfully, it will be promoted to production. So blue green is a concept like we'll deploy both older model and newer model, and we'll route a traffic. So wait, say 10% traffic here. If it behaves properly and improved accuracy, then we'll increase to 20% traffic here. and still it is able to handle that traffic, then we'll increase to 30%. Then we promote it to stage even more load, so that other related service can test it. And once that testing is done, then that container is moved to production. Here also similar manner, blue green deployment happens, so actual 5% of production traffic goes here, and consumer is not seeing any issue, and even testing team is not seeing any issue. They will increase the traffic here, and once everything looks good, uh, you cannot use Docker desktop for that. Docker desktop is for only for laptop or desktop. Only Docker container. Docker desktop is umbrella, means it is bigger thing, means it manages Docker container, even it provides Kubernetes. But Docker desktop is only for laptop or desktop. It is not for production. You need to just create container, and you can run Docker container in any container orchestrator system like Kubernetes or ECS or even Docker Swarm. You can run parallelly multiple containers. So once this testing is done, it is promoted to actual public facing traffic here. And if some cleanup is required, it will do. But so in that manner, we are 100% sure that no disruption in the service to the customer, and they will not see any downtime, and they will get proper model, like better model for their service. Any question for this? Container orchestrator is like, say, you have seen like you have seen cows and that herd. So there is one shepherd, correct? So cows can run anywhere. So it is the task of shepherd to actually make them in line and go to green pasture land to eat grass. Then when it is time to come back, he has to collect. So orchestration is same process. So containers are like cows, means you can it is a collection of all software libraries configuration inside a container. And when it runs, so it solves a problem of it works on my laptop. So generally what happens in industry is that say developer says it is working on my laptop, but if I try to emulate and run same thing on my laptop, since my software libraries are different, that software won't work on my laptop. So that problem is solved by container. Means container is collection of all the things required by that service in proper order and version. Then it is a container, but container runs as a single unit. But if you are having more load, you require more containers. So that's the orchestration platform handles that many deployments. Say there are 1,000 machines and you are deploying 500 containers, so it will find where all I can deploy this 500 containers easily. So that is the advantage of using Kubernetes or ECS to orchestrate. Any other question? So now what prototype to production, like say if we have more model, so we have taken to production, we have seen how we have solved that problem, like how we have taken train model into production. But adopting DevOps or machine learning, so I have shown you full DevOps CI/CD pipeline. Even there are other tools are custom built by certain companies. Which I have shown is very generic. Anyone can use in their company or their institute. But there are some certain software like ML Flow, TensorFlow serving. These are like managed service provided by their service provider. You can use that also. Fourth challenge is model drift and maintenance. And so till now we have seen like yeah. So generally software also we have seen like some bugs can come, and we have to again update it or fix it. Say for example a banking like credit that Paytm kind of or credit like of companies. Say new bank has come now, they have to integrate that their service also. So now that if they don't integrate that banking service and that is popular, so they will lose some market. So they have to keep on updating things. Even customer can request for new features. So similar goes in AI ML model also. For example, you have seen uh, fraud detection model. So say earlier there was a fraud related to, for example, in Ola there was one fraud, like the taxi driver themselves book and take incentive from their friend's mobile. So that was being detected by heuristics earlier. Now AI can be used, but now they have found out new way to. If model is older, the model will not able to recognize new kind of fraud. So that can be the. So we need to keep more updating the model with newer data, since so I have given you one example, say there was one example say one model was trained for normal users and all. One user has created his name was having double Z in beginning, so nobody has name generally. So so say some round of error is like going to that last entry, because one developer has developed as a last user as a dummy user for that. But say in bank that double Z user has come, so all that extra so round of money was going to his account. Then he informed bank. So so that's why his that model is older now. They have to update it to provide the fix. Even in like example of say car training data. So say some car training data for autonomous car, it has been done in US. If it comes to India, certainly it will fail, because there they keep a lot of distance between two cars. But in India, we drive in bumper to bumper traffic. Correct. So here model has to be updated so that it won't if you create a more gap, either bike or auto will come in between as a filler. So that is real world example you have seen in Mumbai. Even I learned my car driving there. Okay. So that is what so as a solution what we can do, we need to keep track of like metrics and logging of that model. And if it finds its accuracy is decreasing, then it has to retrain itself with the newer data. And so since we have created matrix collection, we can even have pager for that for AI team that see model accuracy has dropped below this threshold. Then data science team needs to means manually correct the model. So, it means they have to manually intervene. Sometimes automatic retraining can happen, so this pipeline can go in loop. It's a feedback loop, and again it can put itself and whole pipeline can run automatically. Any other question related to this?
No, sir. Thank you.
Okay, so next demo. Now we'll see.
Tuna Bowlski spelling.
Hello, come again. So we'll see RAG, retrieval augmented generation for say for example, someone is like using command line. I showed you one command line tool which I have created for myself. So but it is limited to AI. It is not like learning new things. Say I learned something new, or I found some new book or document or some new website, so where more tricks are available, AI won't give that. So for that a RAG can be used. So this is the architecture diagram of that. So what earlier I'll read my documents and create everything in encode it in embed in vector database. Means I will read document with say 500 words first, then overlap with the next 500 so that context won't get lost, and I'll create vector database. And once this database is created, the user can ask say server, then it will get some data related to this question, that what is the context and what all related documents are there in say certain, like it is a search engine kind of thing. And once it will combine your question with that context, then you will get more better answer. So we'll see that in demo just now. Okay, so you can see I have documents like I have downloaded this docs. So Regai is a Tamil word, but I've used. So it is a Tamil word, and it is also related to like horn or trumpet, but it means excess or abundance in some. So it is like giving extra data. So that's why I have used. Okay. So I'll show what all documents I have collected. For example, so I collected this document and say, for example, say some file. Okay, so it will show me how to improve the prompt, colorful prompt, or current time in a prompt. And because if you see what is the prompt here, okay, so I have improved already time, but like in some places it is not there. So how we can find out things? So this is the one example. Means many documents I have collected, means only 5 for testing. Then I told you we need cleaning, so I converted it to same a common format so that it becomes much easier to parse. Means it should become text, so it is all text file now, because PDF is not text file. So now I have converted to data cleaning. Then I'll say run, I'll create embedding model. Okay, now I am creating embeddings. Means it will read all those so I see I have written this to md.py. It will convert to markdown files, but so it is reading this small LLM from Hugging Face, and now it is creating embedding in this folder. Sorry, demo, and here it is putting in SQLite database. Simple. And now it is created. So it is saying that, see, I have created and persisted at this location. Okay, so this part is now complete. Now let us ask some question. So let us start some UI. Means I'll start some this server. My screen visible?
Yes, sir.
So see, it is loading, reading the Chroma DB, so that okay. Now let me ask some question which is available in that document. See this. So let us see. I'll ask him this the same question. It should give now answer. It may this will not be shown by Olama correctly, but if I ask same thing here, so let us see. It is thinking. Actually, it is doing the same thing. It is liking context from here and merging it and sending to Olama. Okay. See, it has shown same thing KMS like this document. See KMS, correct. So in that manner, even it shows the sources. See that same file name. We can ask another question. For example, say if I go to docs, another book, say for example, I'll take this. Say you want something. Let us see what it gives. So now you can see it is now accessing your data to show results. Store command line output as their output is C. And what is C? It is exactly kind of same. So that helps in you can use your data without risking any leakage. So that is security. So I'm not using any service outside of my laptop. That is the advantage. See, everything is going here only. Okay. So see, new model is loaded and then it does all these things. So everything is running on my laptop. It has not gone anywhere else. So my data remains with me. So if you have some sensitive data, you need not to go and share with Chat GPT or Google or Meta. It is on your laptop. Any question related to this? I can show one more example to be sure. Okay. Some good examples so that okay. So how to read a compressed file without extracting. So if I do same thing with my simple Olama based model, it will show something else because it is only asking AI model. So it may be written, see, only one thing, Z cat less head tail, not correct actually means. But if I ask here, oh, sorry. It should show something more interesting here. What is the advantage of working on terminal? The advantage of working on terminal is that everything is text there, no distraction. And see, most of the AI related things are currently more biased towards more better results are given by text based things. So with text based things, you are 100% sure your things are going to work. With like UI or because see, location may change. Here, say this is big here. Now here is small. See order change or so there are many things come in when you start using UI. So that's why AI don't give correct results in UI. If I say draw diagram, I mean, so if you say generate picture, it is not 100, my very less accurate, even less than 30% accurate. But if I say generate program, it will generate better program. So that is the advantage related to text. So text terminal is mostly text. So that is that. So you can see it has given much better answer than only even it shows the sources. Hacker noon. See, we have taken from hacker noon only. So let's say it recognize the proper source if I give means question related to it. Okay. Let me close this. Okay. Okay. Now next section. Should I go to next section? So you got like how it was working. Okay. So now last section is that future trends in AI ML. So last 5 years have been like whirlwind. Like after Corona, generally we have seen like a lot of things have changed, and the next few 5 years it will be even faster because we have seen like AI is producing around more than 80% of accurate code. So yeah, so these trends are not just theoretical. I have shown you practical examples, and these are already taking shape and will transform how we interact with technology. Okay. So key trends are like rise of generative AI. Now generative AI has moved more towards not only text, as one question came from Mr. Vijay. So so we are more moving to from text to like images and videos, even audio. Many areas are there. Second is edge AI, so that for small tasks no need to go to server, means server of like OpenAI, Meta, or Google. Even multimodal AI, that I'm multimodal means like more not only text, like audio, video, and even like language translation, many things. And then again more improvement is required in AI legislation and regulation, means laws should be there, how court will handle the cases related to AI. For and then fifth and final one will be now improvement of processing, like quantum computing. What implications it will put to AI, means how it can be used better. Any question for this? So generative AI, we have seen that it uses text to determine the next text next word. So we have moved beyond the AI that can classify or predict, and now building systems that can create. Okay, means earlier most of the AI is related to like generating text, like writing letter to principal to take leave, kind of, or generate the content of say this question, what would be the answer. But it has taken next step in like writing codes which are almost workable, means you need not to write and sit and type too much. So even writing test cases, all those things are there. So what impact it will put, like it will help content creators, like writers, artists, and marketers. Nowadays even in news I am seeing like AI generated image posted by like Times of India and others. How Gen AI is different than XAI. So generative AI is only predicting the next word, but explanation AI is like it has some reasoning power. So it will reason also. So reason is also a kind of generation, but it takes learnings from already done some task. So using that, it will try to improve itself. So it is like a generation over generation, uh, and correcting oneself. And then what so it will be improving the productivity. So we have seen this trend in industry now. Earlier, if one development team requires 10 people, now we can do the same work with two. So that's why major layoffs are happening. Okay, so it will now create another kind of job. When computer came, people were thinking that computers will take our jobs. So computer provided another kind of task, jobs like development, DevOps, and other things. So similarly, AI will help in creating another kind of jobs. The question is like, oh, yeah, so accuracy or score, there is always a scope, because next word generator is always with some like probability, not like perfect number. So always there are chance of improving the accuracy. And uh, and uh, what about ethics? So it is ethics related to the people who are generating the model, and the team which is creating. Most of the ethics lies with them, but as a user we also be use AI for ethical purposes. So there is always two sides of a coin, uh, head and tails. So the people, it is depending on people how they want to use it mostly. But yeah, certainly if strict laws and other things are there, then things can go in better direction. And guidelines. Even AI can have better guardrails for proper mm, ethical implementation in usages. And we have seen like these kind of models, like chat gpt 4.0 and 5, they are supporting multiple multi-model things. Like they can code, they can recognize the data in picture. Just 1 minute. Yeah. Okay. And edge AI is like running on a small for AI in a smartphone drone, so that what is the advantage is low latency, because it is nearby your device, it runs much faster, and you will get data instantly. And enhanced privacy, because data never leaves your device. Hello, sir. Okay, and reduce cost. uh, Third one is multimodal AI. As I told, like it can support more than text, images, and audio, and it has like human-like understanding. Okay, so I'm completing in 5 minutes. This is almost done. Uh, okay, future legislation and responsible AI, why matters. So government and regulatory authorities should implement better laws. Yeah, I'm complete almost. And fifth is the quantum computing. We can use power of quantum computers. They are much faster, and they can solve in other problems like DNA matching and other things. Even they can predict the DNA of coming generations and all those things. Even solving any issues related to DNA like cancer and other things. Those things can be used. Yeah, I'll skip for this, and yeah, that's I can conclude. Any questions for me? And Ravindra Guar sir, PhD research can be done on Gen AI responsibly. Yes, not only models, even how it can be used in other areas. That those are many areas to be used. Means many research areas it can be found. This image is generated by AI, and yeah, thank you. You can contact me on LinkedIn. My email ID is given here. You can post it there also. Okay. Yeah, so governance is there, and every company has to like take this certification from their audit authorities. So that's how GDPR and HIPAA models means. Even if it is a banking related company or credit card, they have to take PCI DSS certification. So they have always compliant and show the certification there. Yeah. Any other questions? Yeah.
Thank you so much, sir.
Yeah.
Thank you, all the participants, for asking wonderful questions. And again, thank you, sir, for answering them with such clarity and patience. This session on ethics, challenges, and future trends in AI/ML was enriched with interactive and real-world examples, making complex idea easy to connect with. The practical discussion provide valuable perspectives that bridge theory with applications as well, sir.
Yeah.
Your strong hold on both the audience and technical concept truly made the session impactful. I hope everyone agrees with me on the same.
Thank you everyone for attending and bearing with me for 1.5 hours.
It was a pleasure, sir. Thank you so much. To all the participants, I'll be sharing session 3 feedback and attendance link in the chat. Please go ahead and do the needful. Again, a heartfelt thank you to Mr. Judd for sharing his expertise with us and to the participants for the interactive engagement.
Okay. So should I stop sharing now?
Yes, sir. Thank you so much.
Okay. Just 1 minute. Yeah, I will stop sharing.
So we have a fourth speaker for the session. We now move to the fourth session of the FDP on the topic AI-based predictive analytics and maintenance strategies. We now invite Professor Manila to deliver the introduction.
Thank you. Thank you, Ramya ma'am. Good evening, everyone. It gives me a great pleasure to introduce Miss Pallavi Dongare. She is an educator and researcher with over 12 years of teaching and research experience in civil engineering and construction 4.0. She is currently pursuing her PhD in engineering and technology at NMIMS, MPSTME Mumbai, focusing on the integration of Industry 4.0 technologies in construction practices. She serves as the director of the International Summer Internship Program at Vishwaniketan IMEET, Navi Mumbai, where she has successfully coordinated global collaborations, international training programs, and student mobility initiatives. She has also been a core member of the Project-Based Learning Center of Excellence and the Business Modeling Center of Excellence at Vishwaniketan. Her research contributions spanned Construction 4.0, Industry 4.0, UAV applications in modern construction, and project-based learning pedagogy. She has authored several Scopus Index research papers, books, and book chapters, and presented her work at reputed international forums. Her international exposure includes visits and research programs at Technical University of Berlin, Avignon University, France, Ural Federal University, Russia, and the University of Malaga, Spain. She has also filed and granted multiple patents in the area of smart construction technologies and wearable safety systems. Recognized with national and international awards, Pallavi recently received the IEI, that is Institution of Engineers India NMLC FCRIT Excellence Award 2025. She has also secured grants with Erasmus Mundus, LIA France, and Trans Engineers India. She has delivered expert sessions in FDPs, workshops, and international seminars, and remains committed to advancing global research collaboration, sustainable construction technologies, and inclusive academic practices. Please join me in warmly welcoming her. Over to you, ma'am. It's a great pleasure for you to be here. Over to you, ma'am.
Thank you, Manila ma'am, for the wonderful introduction. I hope I'm audible to all.
Yes, ma'am, you are.
Thank you so much. I would like to share my screen. Kindly allow me a moment, ma'am. I'm sharing my screen.
Are you getting the option, ma'am?
Yeah, I'm sharing.
Okay, no problem. Yeah.
Is my screen visible, ma'am?
Yes, ma'am. Yes, it is.
Yeah. I'm at my first title page of my PPT. Is it visible, ma'am?
No, ma'am, your PPT is not visible. We are able to see the folder screen only.
Okay. I'll try one second. I'm so sorry for the delay.
It's okay, ma'am. Yeah, now your PPT is visible.
Yeah, thank you. I hope it's in full screen.
Yes, ma'am. Yes, it is full screen.
Thank you so much, ma'am. Good evening, everyone. Thank you all, and thank you, ma'am, for nice introduction. Thank you all the participants for joining this AICT ATAL Faculty Development Program on AI-based predictive analytics and maintenance strategies. I'm Professor Pallavi Dongare. I may face bandwidth issue because I'm at home right now, so I'll switch off my video. If in between, if my voice get interrupt, kindly let me know, or you can type in chat box as well. Before we start our today's session, I would like to give a brief intro so that give me an opportunity that I can explain that though I'm from core branch, how I'm related to this AI world. So I'm Professor Pallavi Dongare. I'm currently serve as a director of International Summer Internship Program and currently pursuing my PhD in technology management, and my research area is construction 4.0. So my academic journey began in core civil engineering, that too into structures because my master's is in structures. But over the years, my work, my exposure gradually shifted me towards the digital transformation in construction industry. As I said that I'm working in international cell at my institute, and as a part of this role, I work with global universities, research labs, and industries. Generally, we create opportunity for students and for faculty, but during this work, during this day-to-day work pattern, I got to learn many more things, that technology development and technology management is a two different domains. We Indians, we are very good in technology development area, but management equally matters because industry needs that as well. So during our international collaborations, I have had a privilege of attending and contributing several international universities. Back in the year 2019, I visited Ural Federal University of Russia and participated in one of the summer university program where I work on a project of smart inventory retrieval system, and that project introduced me to the construction 4.0 concept. And there onwards, I visited the University of Malaga, Spain, under the Erasmus Mundus Fellowship, and I worked on the curriculum development in the Industry 4.0 era. Then I visited University of Avignon, France, and carried out my research work in construction 4.0 in technology management domain, UAV integration in construction sites. Recently, last month, I visited Technical University of Berlin, Germany, where I worked on the sustainable building design in Industry 4.0. So during this all visits, frankly, I can say it was turning point of my life, because from core civil engineering branch, from that background, I was exposed to the ideas of Industry 4.0 for the first time. I was mesmerized seeing how sensors work, how digital twin concept can be adopted in smart city, how data driven system operated, and that actually sparked my interest. So from that moment, I began my journey in technology management area and into construction 4.0 research. So today, my work continues this intersection. I think there are participants from computer science background, but a slightly different domain, slightly different approach and perspective I would like to share today with you all. And I'm really excited to share that insights how AI-based predictive analytics and maintenance strategies can reshape not only manufacturing, not only construction industry, but many industries and beyond our imagination. Here, I would like to sincerely thank my organizing team of this FDP for inviting me as a speaker and for this wonderful opportunity. So today, I'll try to give a focus on how AI is changing the way organizations maintain equipments, infrastructure. So for next 1 hour, we'll connect theory with real practice. How data, models translate, breakdowns, how they can lower the cost, or we'll discuss some practical steps, few practical case studies I came across during my PhD work. I invite you all to note down your questions. As we move along, we'll discuss them at the end of the presentation. So let's start with our presentation. This slide will show you today's discussion. We'll begin with the actual context, with the definitions, with the common vocabulary that you all know, and slowly we'll trace about the evolution of maintenance practices we have. We'll deep dive into the AI models. We will then cover the implementation strategies. I have developed one framework, strategy framework, a step-by-step roadmap you can see, a SWOT analysis about all the strategies. That will highlight the risk also and mitigation strategies as well. So finally, we'll look into my research area, that is construction 4.0 applications, a detailed case study from industry, and how the ROI calculations benefit the industry. And that way we'll conclude with the roadmap. You all know that maintenance traditionally mean either reacting to failure or following a rigid time-based schedule. So both approaches is actually a waste of money and a risk of safety. Here, with the challenge, AI comes as a solution. AI changes by using sensors, by AI actually changes and uses data and historical records that actually forecast the failure even before they occur. So if practically I want to say that AI is transforming and AI is identifying the small and early signs. Even if a tiny vibration occurs, increases, even there's a small change in temperature drift, that machine, that AI will connect to the pattern which are historically laid a larger failure. So when you act on this, on the early warnings, being a being a teacher from core branch, I'll say to avoid emergency stoppage and plan all the repairs in low impact window. AI is the solution, I can say. But before we design or before we jump directly into the solutions, it is very, very important to understand what are the challenges current traditional predictive maintenance facing. Many organizations, they are underutilization of data because records are there, but they are only on the paper. There are different systems, different inspections are going on. I came across, I visited many construction industry abroad, many industries here in Mumbai. And one thing that I have noticed, that inspections are there, periodic inspections are there, but they're often manual. They're infrequent. They are just to maintain or keep the record. There is lack of sensors, there is standard interfaces are not available. And when it is available, even in few industries, it is very noisy, it is very incomplete. When I talk to the authorities, because in construction industry, if you see, there's a lack of proactive maintenance. If at all anything happens, if the machine is not working, then only they'll go and will repair it. And even if you try to ask in that regards, they are very resistant. The different problems they are facing, no doubt, but that reactive nature, that safety risk, that compliance gap, even you can see a limited scalability is there. The current industry, not only construction, but all industries are facing this many challenges, and their predictive maintenance matters. Predictive maintenance matters because the cost of unplanned downtime is very high. It's very high. Not only a loss of production, I can say. Take example of any manufacturing plant. It's not only about the loss of production, but also the emergency repair, the premiums required, the safety risk, even the reputation at this tech. So all this damage can be controlled with the help of AI. You can forecast the failure, you can plan the interventions, it will reduce the organizational cost, it will increase the asset availability, it will maintain your reputation as well. So from management point of view, from technology management point of view, predictive methods support the sustainability because it touches the three pillars, that is people, planet, and profit. Sustainability is buzzword now. No, everyone is speaking about the sustainability, but whether all this technology, all the technology developers, those who are currently studying and working in the computer science domain, they can contribute hugely because they plays a very important strategic role. Strategically, when when we perform the maintenance, our each and every action and activities link with the KPIs. So it's aligned with your goal, and it becomes very, very important. So what I want to say that predictive maintenance and all the strategy becomes a clear catalyst and contributor in today's competitive advantage and long-term market scenario. Here comes the definition of this maintenance. Predictive maintenance is what I learned, what I came across in last 3.5 years. Health and to forecast the probability and timing of that equipment's failure. Am I audible?
Yes, ma'am. There was a break, but right now you're audible.
Oh, I'm so sorry for the poor network.
No issues, ma'am. Ma'am, even now there is
I
a
hope my screen
small.
is visible, ma'am.
Yes, ma'am. It's no, not yet, ma'am. Your screen isn't visible yet. Yeah, it started now.
Where? Actually, I'm right now in slide number 7.
Yes, ma'am. Correct. You're in the slide 7.
Yeah. So here we were discussing the definition of predictive analysis and analytics. Here we begin with the practicing the using sensor data. So unlike preventive maintenance, here we actually generally in traditional maintenance we uses the calendar at the fixed interval. When I visited BG Shirke construction site, I came to know that they are managing all 4 M's of construction, that is man, material, machinery, and money manually. A fixed interval. Decisions were taken based on conditions and trained information given by the calendar. So different here, inputs can include anything. Inputs can include the vibration, can include the temperature. So in predictive maintenance, utilizes AI, sensor data to forecast the equipment failure. An input can be in terms of temperature even the signals, images, health score, and that can be utilized to find out useful life of product, to find out the failure patterns. So the power of this approach is that it minimizes both unnecessary service which is required and unexpected breakdowns that happen. But why it is important then? It is important because historical data and failure records. The process begins with the feature of extraction over here. So when we transform a raw signal into meaningful indicators, let us say a temperature drift is there, variation is there, and which is not quite frequent. So when we label this for the past tenses, you can categorize that whether it is healthy or not. So it is very important to forecast the failure, but which allows the timely maintenance and which reduce the downtime. That is very important from efficiency point of view as well. So there are different approaches, as you can see on the screen. There's a reactive maintenance, preventive maintenance, predictive maintenance, and prescriptive maintenance. Reactive, the name itself indicates, it is very simple, but it is very, very costly because it waits till the failure occurs. Whereas preventive maintenance is the scheduled one. You can say it is risk over the maintenance because it reduces the failure risk, it acts on the schedule, but often it is over service part. For example, the maintenance is planned for so and so date, you have to act on that. So whether it's needed or not, you have to perform that. It's a kind of calibration. So it reduces waste. It creates the waste sometimes. It sometimes unnecessary, we can say. Whereas prescriptive maintenance takes predictive maintenance further because it is the best corrective action AI suggests us. Here we can replace, repair, re-lubricate, reschedule our actions. You can consider any spare lead time, whether the crew is available, whether the staff is available, whether the production is getting impacted, and each step requires more data and integration. So the value of the downtime reduction and efficient resources increases much faster than the incremental cost when implemented in very short time. Let us discuss about the maintenance evolution. This is also very important because any organization, any industry typically progress along the path. When you start with the basic data collection, then it's easy to detect the anomaly. It is easy to move for the predictive model and to estimate the usefulness of that product. So ultimately, the logic says, for example, a practical pathway says, we have to pilot that product for the few critical assets. We have to collect and clean the data for several months. And then we implement a simple detections on the dashboards. Then we built a model using the series of event happened. We scale up that slowly. And then once it is proven, and then we go for the ROI. So it's very important that one should go with the analytics that what happened, why did it happen. That is called as 5W2H approach. And with that approach, the evolution reduces the risk and it allows management to see clearly that before we go for the very wide investment, whether we are getting a very good ROI. So being a technology management expert, the focus, the final outcome is very important in terms of ROI. And AI enables that transition from not only from reactive, but from predictive to prescriptive maintenance. So here comes the strategic importance of this move. From management perspective, predictive analytics and maintenance, all the strategies in this area, they align with the operational practice. So they are operational with the, and they are in line with the core KPIs. What are core KPI? KPI, the key enables the performance index of that industry that can minimize the uptime, that can provide the spare parts, inventory turns, that can provide the maintenance of labor hours. So when these all metrics improve all together, they directly affect the revenue, the cost, and the customer satisfaction. So it's not only about the ROI, but it is all about it support the compliance report well in advance because we provide a logs, checks, and a periodic interventions. Being a technology manager, It is I can say a key in today's generation, because it gives us the hours of production saved, the cost avoided by preventing a single critical failure. So a person in management role or the leadership of that activity can understand the tangible effects of this strategic move. Let's move toward the role of this analytics and maintenance in today's era. As I said, that AI fulfills several concrete functions. That anomaly detection is there, failure analysis is there, optimal maintenance scheduling is there. As we have just discussed, that asset and product health score is very important. Even if we come to know that there's a problem, the root cause analysis, the emergency response time get reduced, and energy efficiency optimization can be done. With all this regression, with all this time-to-time failure model to estimate remaining useful life, a root cause analysis to suggest why the fault has happened, and to assess the health of scoring, to prioritize, we can say, to interventions, to schedule the optimization, we can say, to find the best time for the repairs, we can say. AI plays an important role. Combining all this, AI already have proved their capabilities in decision-making support, and they have reduced the guessing, or that have empowered, we can say, our technicians to act on the trusted signals. So what are that key technologies which we have? What sensors platform we have? A predictive maintenance is a solution, and is a solution which provides the ecosystem of sensors. As you can see on the screen, there are different sensors available, like which I came across is accelerometer for vibration, thermocouples for temperature, ultrasonic detectors, cameras. So there are like edge computing for pre-processing, secure communication, big data storage, analytics platform, model deployment. There are many, like digital twin currently I come across for the simulation. So this all, even the digital twin let you simulate the scenarios, test the fix virtual platforms. My students were working on the computer vision, on the drone, on the UAV. The application was on construction site, but that was very, very interesting to know that the practical design choice is matching all the sensors, the type of which is dominant for that failure model, even reading the vibration sensors for rotating machinery, for the thermal sensors, for the bearings, for the electric joints, cameras for the surface detects. All these technologies can be used ultimately and strategically to get very good ROI. Moving towards the AI techniques, I am not technology developer, so I'll not go much deep into it, but I'll try to just touch this algorithm, that whenever we choose AI as a technique based on the type of problem which you will come across, unsupervised methods, or like just simply clustering the data, or clustering a labeled failure, is of no use. We have to randomly forest or boost the work. So whenever failure occurs, whenever there's a label of failure, a time series model we need to deploy. CNN is the best for the image detection, right? So reinforcing all this learning can help in dynamic scheduling, and ultimately it will model first to gain trust in technicians as well. So deep learning is there, data mining is there, all these methods or all these techniques, algorithms enhance the accuracy, and that will actually recognize the pattern to finalize the final failure pattern. Even data pipeline for the analytics says that it begins, we can say, carefully with the place sensors, with the correct sampling rates. Raw data is pre-processed, like filtering is there, then removal, So sometimes extract the data, then we train the model to produce the alerts or health scores, which are shown on the dashboard. And then finally we integrate for the real-time monitoring, and then feedback loops are there. These are very, very important because operationally attention is to timestamp, to synchronize, to find out the missing data, handling that data, and securing the transmission is very, very important. So the way machine learning model is trained, finally the feedback loop completes it, and then that product operates. There are machine learning models as well, because let us make that models concrete and use all regression to estimate all your remaining hours for the failure. And for that, you have to give the warnings, critical situation, you have to detect the failures, labelings. So in practice, a hybrid solution frequently works the best. I've seen hybrid means it is in light of interdependent, we can say, where real-time alarms, real-time data detection, and more sophisticated predictor. They runs both parallel for the planning purpose. So you need to classify that, and then with the help of deep learning for the image, for the video analysis, that we'll discuss in case studies that I have come across. But yes, that classification is very important here. Now let's move toward the maintenance strategy, that how it can combine this both approaches. So this section will give you an outline about the various maintenance strategies which we have. As I said, that AI allows a balanced maintenance policy. So whenever we keep preventive check for safety critical assets, we use predictive monitoring for the assets, and we use condition-based triggers also for the remote assets. So in a policy matrix, I can say that to downtime the cost of any activity, the mapping is simple but yet powerful, because that tool actually gives us and ensures the resources that are focused where they actually matters the most. So the first one is condition-based maintenance, CBM. That is a very practical insight, I can say. CBM focuses on acting when measured conditions deviate from the acceptable range. For example, I can give an example of motor vibration. Spectrum shows that there's a rising peak at a bearing frequency. Means a flag will be given there that it identifies that it is deviating from the normal pattern. The pattern is changed. I can give one more example, that cement plant that implemented on CBM. It will report you that there's a significant reduction in the final production amount of cement in kgs, or it has stopped, and that trend is acted upon a type of dash failure. So what practical lesson is here? That CBM is often easiest step, I can say, where machine status is actually visible in terms of result. There's a real-time monitoring of critical assets. The second one is predictive maintenance. Here you can see a workflow pattern is detected. So AI predicts when failure is likely to occur. A typical predictive workflow, a sensor stream data is there, a device is there, it extracts all the features, and it sends the summarize to the cloud, and it gives the score, which estimate the remaining useful life of, or the risk band of that particular product. So I can say this works on the workflow pattern, that raw data is there and the planned action is there, and measurable saving or replacing emergency work pattern schedules. The third one is prescriptive maintenance. That is, you can say a decision logic maybe, and reliability centered maintenance. First, we'll discuss the prescriptive maintenance. Prescriptive maintenance converts the prediction into recommendations. It recommends you to take the action. So it factor the spare availability. the crew schedules. For example, in term, if I give an example of any construction site, you can plan the dummy activities in between. For example, ground floor construction is going on, but at the first floor, you can go for the plumbing. So the parallel activities you can plan based on the manpower available, based on the machineries available, based on the money available. And that will give you the production windows. For example, when gearbox health is the score is in not good shape, it will give you the band or warning, and that will peak into the production. So this optimizes both direct repair cost also and indirect production loss also. You can act or you can parallelly go hand on hand. Whereas reliability centered maintenance helps you to prioritize assets by evaluating both. What both? The first one is failure and second one is consequences of failure. So two different scenarios are compared here. For example, automotive assembly line is there. There's a failure of a robotic arm, or there's a halt in production, you can say. So while secondary conveyor failure might only cause the localized issue, and that will ultimately stop the production. So here RCM, reliability centered maintenance AI, will let you allocate monitoring and maintenance budget as well. So it is not only about giving the only the failure pattern. It will give you the consequences of failure that occurs. It aligns with the risk management strategies as well. It gives you the compliance report that if the failure is there, the budget will be overdue, or that there will be a reduction in the production by this percentage. So operational risk and cost effective way is also given over here. The next one is digital twin enable maintenance. This is also one of the very important and practical example I came across, because digital twin is widely used for the smart cities, and there I came across one virtual model that was fed by the real-time data, and that model was allowed for the simulation and possible interventions without impacting the real machines. Let's take example of any gas turbine, let us say. So what basically digital twin means? It is the replica, virtual replica of physical model. So that twin combines physics and operational data to forecast the, you can say, the blades of that turbine. And then that was modeled different parameters. The immediate values of that turbines was given there, and then it increased over the time. So we can say a telemetry type of failure data they have calculated. So it reduces what? A testing cost and downtime, a maintenance cost they have reduced here. So this approach actually reduces the upfront cost. So this replica reduces your testing cost and downtime effects of that. So it gives a incremental improvements, you can say. It is not that all of a sudden that without testing you are going for that, but digital twin, as it is the new concept on market, I can say it gives the incremental improvements in your model. The next one is autonomous maintenance. Drones, I can say robots, and in the industry 5.0 concept, cobots. These all are example of autonomous maintenance, where autonomous maintenance is the example I can give is drones, which we can use for the inspection and for the simple repairs in construction industry, because drone captures the high resolution images with the help of computer vision to detect the cracks, corrosion in structure. Whereas Industry 5.0 says that cobots can assist the technicians by doing the repetitive tasks. Lubrication task is there. So that maintenance can be done with the help of cobots. So especially complex sites, suppose bridge construction is going on, a very tall chimney construction is going on. In active construction zone, there's a risk parameter is there. So we can use autonomy, we can use human workers but not to replace them, but to help them, to guide them, to support them. Automation and skilled staff to focus some exceptional work which are very high value. We can minimize the human risk exposure there, and we can use the cobots and robots. So that maintenance can be called as autonomous maintenance. And the last one is optimization based maintenance strategy, where optimization based maintenance strategy reduces the waste in inventory. It improves the crew deployment. As I said, that predictive models indicates which part is likely to fail and when. So algorithm can detect, it can point out and quantify the minimum combined holding and stock out cost. A crew or a labor or worker in an industry or on construction sites, we can schedule the algorithms because there are unskilled labor, skilled laborers, and semi-skilled labor. So depending upon the activity, depending upon the maintenance activity, construction activity, by reducing the minimum travel time without interrupting their daily work schedule, we can improve and we can give a small percentage of gain with the help of optimization based strategy. So all I want to see that a predictive maintenance system that needs a clear governance. Who owns the sensors? Who owns the model? Who act on the alerts? How this is defined in terms of response? Who is training the model? Even the data governance is also essential. Access controls are also important. Retention policies are also important, and the most important one is security measures. So we need to invest. We need to connect this with the balanced investment between old and new assets, and that actually support the digital transformation. So with all these challenges, with all these problems, I finally, me, my team, we come up with one roadmap, a strategic framework that one should use. As you can see on the screen, this figure gives the idea about the practical strategic framework that includes how assets is selected based on downtime cost. And then we can begin with 3 to 6 month time. We can install small sensors. We can collect the data. That is called a digital beginning. And with that beginning, once you find out the detection, once you demonstrate the impact, next is go on building the predictive models, integrate the results with the dashboard to maintain the system. And after a year or two, scale up that site. Go for the standardization, go for the data schemes, go for the feedbacks. And finally, you'll come across with the training programs, with the KPI. That is nothing but the level number 4. This roadmap will give you a very good final best practices. As you can see on the screen, there are different best practices in AI predictive maintenance. We need to quantify that examples. Data management, which actually means finding the data quality, reprocessing, integration, security, and privacy. As I said that your cost benefit ratio and ROI also plays equally important role in that. So data governance is essential? Yes, because it defines the access controls, a retention policies, a security measures. You need to invest on the technicians? Yes, because you need to finalize the model selection. You need to finalize the rules. You need to train the team. You need to understand the model outputs. You need to validate the alarms. You need to finalize the governance and the people and the elements that are often decision-making factor between the success and adoption. So all these are strategies, all these are important 5 clusters, I can say, which are further divided into categories, which will ultimately lead towards the implementation of the strategies. Here we comes with the SWOT analysis of the strategy. Like if you see, as I said, that practically this framework includes selection and all, but there are strengths. When you apply any roadmap, the strength says that it early detects, it improves the uptime, and it enhances the decision making of any data driven insight. Whereas this strategies also have weaknesses. The weaknesses are it has very high initial investment, data privacy and security concerns are there, and it requires a skilled workforce. Right now, for the AI adoption, we do not have the skilled workforce with us. There are many opportunities because integration of IoT and digital twin in real-time monitoring has a great potential. As it will expand this industry and it will give us standard operating procedures to the many industries with a very good ROI. So that is the biggest opportunity we have in this domain. There are some threats as well, like cybersecurity related. Still, we do not have any legal framework for that. We have risk over the reliance and compliance challenges in the data uses as well. So this SWOT analysis sees that actionable mitigation includes what? It includes a small pilot, a small standard regulatory audits that can be structured, that can be trained to build a skill. So if we focus on the strength and opportunities, if we focus there, then we can definitely work it out the implementation benefits of this. So ROI examples I can give you. Like let's quantify the example. Suppose a machine fails twice per year. Is a one manufacturing plant is there, and take example that equipment enhance the efficiency point of view. I'm saying that take example that machine fails twice per year, and it causes 4 hours downtime each time. If that machine is not working, 1 hour downtime cost, let us say 20,000 rupees, and the downtime is 4 hours. So 2 times failure cost, you can calculate annually, it will be like 1 lakh 50,000, we can say. So if we go with the predictive maintenance, that will reduce failure and will nearly save minimum 70 to 75% of cost per year on that machine. I'm saying per year. So if you multiply that across multiple assets, multiple sites, multiple different processes. As I said that it starts with one small process. There are multiple processes, multiple machineries are there. And it's not only about machinery, it is about manpower. So this will give you the ROI calculation. Just quantify that. There are indirect benefits on the safety incidents happening, the emergency procurement cost, the longer asset, and that actually amplify the financial case as well. So here we comes with the ROI. It is very important, direct savings and indirect savings, and that is a capital efficiency from the assets. That from that point of view, all these strategies and their implementation is equally important. Even if you see, if you look at this diagram, the transformative benefits of this AI powered predictive maintenance, there are many. Few I tried to categorize over here and to write down here, that if you talk about the benefits, as I said, it's not only about the minimizing unplanned downtime, but the customer satisfaction is very important. The better resource allocation, which is missing here in India, is very important. Along with all these benefits, construction industry, which is one of the very important industry right now, which hugely contributes in the GDP of any nation, will ultimately give boost to economic expansion in the world canvas. Let us say a industry, construction industry, with AI, with predictive maintenance, with safety and security, how can maximize the benefit? There are many case studies I came across. The smart helmet and wearable safety model, AI enabled cranes and mixers, drones for site inspections, then BIM integration for scheduling. In the Avignon University of France, I studied the drones for site inspection, and the structures, they created 3D models, they integrated all the schedules. Schedules means not only about the day-to-day construction activity, it was all about aligning the material delivery, the maintenance of equipment. For example, crane showing the different stress patterns, and that can be scheduled for the maintenance for heavy lift, and that actually delays, that actually prevent the delays, and that actually prevent the safety risk. It's safety risk of workers, asset, health, construction site, and ultimately nation. I'll give a small detailing about how they have used IoT in construction. This was the real case I came across. There's one of very reputed builder, which I personally visited last year. He's from Panvel, Navi Mumbai. And one of their high-rise construction project, a worker, one of their labor unfortunately fell from 14th floor and he lost his life. And that incident highlighted a very critical safety gap. So they exercised and they started analyzing the root cause of this event. That builder approached my institute they with the question that how can technology prevent such accidents, such incidents that happen on our site in future, because it is difficult to manage, it is difficult to protect such incidents where we lost one of our labor, one of our worker on the construction site. Then we gave a deep thought on that, and then we come across that a smart wearable system which integrated sensors, let us say a helmet or a safety gear on head, that can monitor actually the motions, no? That can actually give us the temperature, proximity, and different alarms. So data from wearable can be combined with the health of worker. Here worker is asset, and that data enabled a different context. For example, if heavy mixer shows abnormal variation, if there is any speedy vehicle is passing nearby and worker is standing nearby, so that system will issue an immediate notification to both, to operator also and to site manager also, and this can be combinedly enhance the worker safety. That will ensure the maintenance team that can act, emergency team we can say here. A maintenance team is an emergency team that can act before that minor machinery issues becomes a dangerous one, even that accident happens. So as I said, that roadmap is there. That roadmap gives the idea that first step itself is digital beginning. Digital beginning where we looked at the IoT based solutions. A simple wearable device can be introduced for a small process. Let us say a helmet. That helmet is embedded with the sensors, and that could detect the motion, the body posture, the risk of fall, or the day-to-day activity of that labor. That will allow the site manager or the supervisor to get the basic alerts whenever the unsafe conditions are detected. The second step says that we must go with the horizontal integration. So all the data from multiple workers, those who are wearing that helmet, that will be combined, that will come across on a site in a single platform. So now manager could monitor not just one worker without a physical exercise, just sitting in a room, he can monitor entire team in real time, ensuring safety protocols across the site. The third step, as per my roadmap, is vertical integration. So here you can see at this stage, safety data is connected upward with the management dashboard, and then predictive alerts about the unsafe conditions were not only visible to site supervisor, but also to the project manager, to the company leadership, and it is real-time data. It is real-time data. So this is created accountability to all levels. So all these stakeholders will be connected. And finally, we move towards the digitalization. So here you can see in future stage, all the sensors, all the models, they work seamlessly. The system does not only raise the alarm, but it also recommend the preventive actions. It will give you the exit area. It will give you the GPS location that where exactly you are. So it will restrict the access to risky zone. It will send automated warning systems or planning safety drills in case of predicting any risk. So from any tragic incident that happened on the builder side, the journey began with that wearable safety gear. After integrating all horizontally, vertically, moving forward, backward, we finally designed that model. We filed a patent. We come up with the safety ecosystem. We implemented that on site, and we got to know that how predictive maintenance based roadmap and strategy can extend beyond the machines into saving human lives on construction sites. No doubt, here the challenges remain. The cost of adoption is there. The workers' acceptance is also a challenge. Integration issues are there. Data security issues are there. But for sure, this system defines the safety in construction. Even on Google, I came across many case studies. Indian railway system implemented the axle bearing temperature and vibration monitoring to detect overheating, mainly in summer season. Because in practice, that telemetry flags are there to train the temperature and to turn that hot box. But the benefit of this AI, which detects the overheating, a single prevented derailment of train or of rail, avoid huge cost. It saves the life. So Indian railway case study, if you go through, you'll come to know that they demonstrated relatively very simple sensors, a simple rule-based analytics, but that has produced life-saving results. The second case study I come across is Uber, a fleet service. What user is doing, the AI is actually a telematics format that collects the engine, collect the data from engine, brakes, tire metrics, combined with the behavior of driver data to predict vehicle health, centralize all that data, that analytics identifies whether vehicle is at high risk, and schedule the maintenance. But when to schedule the maintenance? Maintenance is scheduled during non-peak hours. So even for the campuses, for the institutes, those are having daily bus facilities, they can have a similar type of telemetry to reduce the roadside breakdowns, to reduce the maintenance surprises that they get all of a sudden. The next case study is of Coca-Cola, a manufacturing plant. Coca-Cola, that bottling plant is there. They have very interesting fact. They have used the torque, vibration, and sensors on conveyors. So means to predict the stoppage, to preventive alert help maintenance, they have replaced it with the worn parts. So what is there? They schedule the brief downtime for the repairs, and they have reduced per bottle downtime losses and energy use also. So they have used the preventive maintenance strategies in the bottling plants of Coca-Cola. Just torque they have used on the belt conveyors and filling machines to predict the stoppage. And that way, that machine stops while filling the bottle. Even the case study of heavy plants, turbines, Siemens, they also monitor their turbines in their mini plants, because blade get degrade. The imbalance is there, the wear and tear is there. So that overhauls instead of emergency outage, spare parts planning, and longer turbine life is very important. There are many case studies available. They all highlight the applications of AI. Aerospace players, manufacturing industries, energy sectors. All companies track thousands of signals per flight to feed the telemetry into models to predict likely the part wear and tear failure of windows. And the business model shift is very important over here, because this is new upcoming area from commercial point of view, from commercial offerings, where customers play availability rather than raw engine. You are there to utilize AI algorithms. You are there to develop AI algorithms. AI, machine learning in healthcare, in transportation, in oil and gas, in agriculture. If you see here, in agriculture, the sensors and drones powered by AI, they can analyze the soil, water, crop health. They can guide farmers for the precision in farming. And there's a future prospects as well, because while expanding all this into large scale, a smart farming is expected, and we can reduce the current ongoing problem of agricultural, that is, we do not have the resources to use, we do not have manpower to use. Higher productivity is the issue, so that all can be addressed with the help of different strategies. The case study of aviation, just now we have discussed. That case study of telecommunication is also very interesting. If you see that machine learning models predict the network congestion, and they enhance the user experience as well. So chatbots are there, virtual assistance is there, and a wider deployment is possible in future time, in 5G, 6G, where self-optimized networks, seamless global connectivity will be our next agenda. If at all we are planning this, then there are challenges. Challenges are very real, because all this case study gives us the very good business model, but data quality, the labeling, the skill gap which we are facing, the cybersecurity, the deployment cost, these are fixed. These all are challenges, and that provide the future as well, because there are some future trends as well. If you tackle all these challenges, that will ultimately lead towards the explainable AI, integration of AI, autonomous and self-healing system. The practical approach is to plan a human validated steps. The moment we accept this, we invest into it, we train our model into it, we adopt the technology, we promote it, it becomes smooth. So what I want to conclude with this, that AI based predictive analytics and maintenance is both. It's practical and it is strategic. All the way we have to start with a small, with a slow process, with the slow value, with a very measurable KPIs. We need to prioritize our critical assets. We need to expand with the training and governance. We must focus equally on the sensors, equally on the technology creation, development, data quality, models, and human adoption. When it is implemented well, predictive analytics and maintenance reduces cost, it improves the safety, it supports the sustainability goals, and ultimately it is a key for a success which is driving the change in today's era. So my final suggestion to all the participants over here, that pick one asset that you can monitor this month, whichever field you are working, with a very small, low cost sensor. Treat any problem that society is facing right now. Future ready firms, future ready AI, a small product that can give a very, very big change. And that way we can start with the small pilot study over here. Core AI technologies all are actually driving a change, and this AI can actually a catalyst not only in technology creation, but at the maintenance, not just like a tool, but as an approach. And that will actually give a smarter, safer future to us, to all. That's all from my side. Thank you. Thank you so much for your attention. I would like to take questions. Any questions?
Ma'am, there are few questions in the chat box.
Yes. Yes. On construction site, it's not only about working on the floors or the heights. The type of model which we have designed, I can say it will give all type of data. It's not only about one sensor which will give idea about the fall detection. Even the proximity sensor is there. Even you can say a oximeter sensor is there, which will monitor the oxygen saturation level of that worker in their blood. The pulse oximeter sensor, I can say, which will identify that whether the oxygen level is going below the safe level scenario, and that will indicate a potential respiratory issues with the worker. So it is like there's one hand you need and one helmet you need, and they both will give different types of idea, different about details, like image device is there, surrounding this parameter sensing model is there, sensing devices are there, location sensing model is there, vehicle to everything communication is there. So we can address such a complex problem where worker is at risk, or any person who he or she is working in that site, whether it is height or it is a zone which is risky, or whether that human, that worker itself is not fit and fine. So IoT based variable assembly will give you a complex solution to health, that is physiological parameters as well, and the surrounding parameters as well. In both cases, in both risk parameter, that will give idea to the that site engineer, supervisor, and the project managers of that site well in advance. So whether it is fatal or not, that is secondary, but it will reduce the emergency response to that incident immediately. If at all that worker is not feeling well, though the site condition is very good, but that worker is not well, so that band will give you the idea that he's suffering through the temperature, he has not taken appropriate breaks during the construction work pattern, and he needs the attention. So that type of alarm will avoid the consequences of that event further. So that way we can actually minimize. I hope I could answer your question. Yes, sir. Yes, sir. So industry 4.0 is related to manufacturing plants, we can say. It is the automation and current trend of automation in manufacturing industry, whereas construction 4.0 is the application of few industry 4.0 technologies in construction sector. It is not about only material. As I said, that there are 4 M's of construction: manpower, material, machinery, and money. So this all we can plan together. That all can be optimization can be done, and that will lead toward the sustainable construction. That is construction 4.0. Yes, we can integrate sensors. That is reliable. It is absolutely reliable, because see, the construction industry on paper shows there are only 3 to 4 incidents happen on any site in a year, and we all know that's not true. That's not true. Productivity and efficiency of machine is very important, but we must focus on reducing the injuries, improving the PP compliance, and optimizing the emergency response time, because human is very important. Manpower is very important over here. So for construction site, if you make use of the sensors, it is economically viable. It's very cheap. When we design that smart wearable assembly, that helmet and that band, it cost around 3,000 rupees to us. But that was just trial and error we were doing. I think we can optimize that in better way, and that sensors will process all the information, and that will reduce many more consequences that happens further. So it has a very good ROI, I can say. Yeah, because in my opinion, it addresses safety concerns, compliances. It improves the operational efficiency. It will give a very good output. And the important one is customer satisfaction. Nowadays, we try to assemble one fan with that helmet, because when I visited industry, I came across that there are few laborers, workers, they have not worn their helmet. Out of curiosity, I asked them that why you have not using that. They are charging you the fine, and why you are paying the fine. They said that it's not comfortable to wear the helmet. The day-to-day helmet they are not using. So whether they'll use this sensor-based helmet, yes, because it will be a customized one for that labor. It will have all type of different new technologies. Even we try to provide one fan. If the temperature is very high, automatically that fan will turn on and it will provide a comfort to that worker. So if you work that worker specific, definitely I think that can change the whole dynamics of industry. Disadvantages is yes, because during the interaction I came across that there's a resistance. The workers, managers, they all are not actually willing to adopt this technology. The one is workers are they have misconception. There's a myth that AI will replace us. This technology will take our job. And the second one is they don't want to upgrade themselves, because see, all these technologies will promote them, will change their blue collar job into white collar job, but but the faculty, student, the civil society, each and everyone need to upgrade themselves. So worker need to upgrade, they need to use, they need to work in collaboration with the machineries, and they are not ready to it. Means they don't want to train their workers, and workers do not want to get trained. I can say there's a resistance. This is the ground level reality I came across. Industries are also not very much sure, because they are saying that the ROI is big question mark, and why we should invest on our workforce, why we should train them. So that training factor, the cost associated with the training is the main problem, where I think they think that 40% project cost will get increased if we try to implement all this. So they are okay with if anyone is not using any technology. They are okay with it. They are operating everything manual. They are writing daily attendance, the inventory on page, on walls, but they are not okay to use different sensors and to minimize the repetitive task with the help of machines, because there's a myth. And yes, uh, there's a resistance from even management level people that that doesn't come our region. Disadvantage wise, the initial costing is required. Maintenance cost will get reduced, but initial cost to start with any digitalization is there. That is there. That is not disadvantage, I can say, but that is the drawback in today's scenario, we can say. Once that initial beginning is done, then that process has a very good ROI in long term. Yeah. Any other question?
Thank you so much, ma'am, for answering the questions.
Thank you. Thank you, ma'am.
You're welcome, ma'am. Thank you. I will now share the feedback in the link. That would be for both the session, that is session 3 and session 4. If someone have missed out on filling it, you can do it right now. Thank you, participants. Uh, I now would take a moment to thank you, Ms. Pallavi, for such an engaging session. Your insight on AI-based predictive analysis and maintenance strategies have provided our participant with both practical knowledge and futuristic perspective. Your clear explanation of complex methodologies and some very important case studies gave participants a strong understanding of how AI is reshaping maintenance and reliability practices. By highlighting transition from reactive and preventive maintenance to predictive and perspective approaches. Thank you so much, ma'am. Thank you for thank you for your time.
Thank you, Ramya ma'am. Thank you, participants.
Now I request everyone in the meet to switch on the camera so that we can take a picture. I request Professor Shahjahan ma'am to take a picture. Thank you so much, ma'am.
Participants are requested to turn on the cameras.
Not allowed to turn on the camera.
It is restricted.
Yeah, you can try now.
It is disabled by now.
It is,
Yeah, right now that is okay. You done?
Yeah, thank you everyone.
Okay.
Thank you all.
Okay, bye.
Yeah. So we have come to the end of session for today. Today, through sessions by Mr. Mitesh Singh and Ms. Pallavi Dongare, we explored the ethical challenges and future trends in AI/ML, along with AI-based predictive analytics and maintenance strategy. Both sessions added tremendous value by combining industry practices, research insights, and forward-looking approaches. With this, we conclude day 2 of ATAL FDP. On behalf of Risby College of Engineering, Computer Department, I sincerely thank our speakers for their valuable contributions, participants for their engagement, and organizing committee for the effort and behind the scenes. We also remain grateful to our principal, Dr. Varsha Shah, the management of RCOE, and AICT for their unwavering support. We look forward for your enthusiastic participation tomorrow for day 3. Thank you and have a pleasant evening. I have shared the feedback links. I request everyone to please fill the feedback and attendance link for today. Thank you all. Thank you for joining. Have a good evening.
Thank you everyone.